Good morning, friends. In good set, from 2017 we start our discussion about the MCQ question. First is, in Davison-Galvez experiment, electron emitted by filament is accelerated by the voltage V. Now, its de Broglie wavelength is denoted by which of the following equation? Now, already we know that in Davison and Galvez experiment, as the current passing through the filament is heated and electrons are emitted from the filament. These emitted electrons are accelerated by the V volt. So, what is the de Broglie wavelength of the emitted electron? Now, here what are the electrons are emitted by the filament are accelerated. That means, as we apply the external voltage, so its kinetic energy is going to increase. That means the kinetic energy of electron is going to increase. Therefore, the kinetic energy of electron half into V square is equal to E into V. We know that the de Broglie wavelength lambda is equal to H upon P. And due to that result, we have to substitute the value of momentum of electron in terms of applied voltage. Therefore, 2 is taken this side. Therefore, m square is equal to 2e. Multiply both sides by m. Therefore, m square is equal to 2evm. We know that there is the momentum P is equal to mv. So here the m square is square, that means the momentum square. Therefore, we can add P is equal to mv is equal to under root of 2evm. And de Broglie wavelength lambda is equal to H upon P. Substitute the value of momentum P here. Therefore, H upon under root of 2evm. That is the de Broglie wavelength of electron emitted by filament and accelerated by the V volt. Again, we want to mention the equation of wavelength, de Broglie wavelength of the electron, which emitted by the filament and accelerated by the V voltage. Therefore, the kinetic energy of electron half of square is equal to E into V. Take the 2 in this side. Therefore, m square is equal to 2ev. Multiplying both sides by m, mass of an electron. Therefore, m square is equal to 2evm. Taking the square on both sides, therefore we obtain the left hand side is m into v. That is the momentum of an electron. Therefore, P is equal to mv is equal to under root of 2evm. Now, de Broglie wavelength lambda is equal to H upon P. Substitute the value of P here. Therefore, lambda is equal to H upon under root of 2evm. That is our answer. It is the de Broglie's wavelength for an electron emitted from filament and accelerated by the V volt. After that, the next 2018, wavelength of proton having the 35 electron volt energy will. Now we know that energy of photon E is equal to Hf. Is equal to Hc upon lambda. Is equal to Hc upon lambda. Because we know that the frequency is equal to C upon lambda, here we require the wavelength. Therefore, we convert the frequency into wavelength. Therefore, energy E is equal to Hc upon lambda. Therefore, lambda is equal to Hc upon. Now listen, energy is given in electron volt. We have to convert into the joule. Therefore, substitute the value, all value, we get the answer is 35 into 10 is to 12. That means we get the answer at this way 0.3549 into 10 is to minus 10 meter. We convert in that form 35.49 into 10 is to minus 12 meter. As is substituted the way of H, C and E. E is given in electron volt, we have to convert into joule. Already we converted this way the energy from electron volt to joule. Okay. Yes, it's the Planck's constant 6.6 into 10 is to minus 34. C. Velocity of light in vacuum 3 into 10 is to 8. Clear? Okay. So thus we get the answer is our A 35 into 10 is to minus 12 meter. Next question asked in 2018. Uncertainty in position of electron is 10 is to minus 10 meter. Now uncertainty in its momentum will be how much kg meter per second. The uncertainty in position is given 10 is to minus 10 meter. We have to find out the uncertainty in momentum. So Heisenberg's uncertainty principle. Delta x into delta p is equal to h upon 2 pi. H upon 2 pi. We require the uncertainty in momentum. Therefore, delta p is equal to h upon 2 pi delta x. H upon 2 pi delta x. It is substituted the value. Therefore, delta p is equal to 6.6 10 is to minus 34. Divided by 2 pi 3.14 delta x 10 is to minus 10. Therefore, we obtain the answer is 1.05 into 10 is to minus 24 kg meter per second. Kg meter per second. Because this 10 is to minus 10 goes up, becomes the 10 is to minus 24. 3.14 into 6.28. Here 6.6. 6.6 divided by 6.28 into 10 is to minus 24. So we get the answer 1.05 into 10 is to minus 24 kg meter per second. That is the uncertainty in momentum of an electron. Again, the uncertainty in position of electron is 10 is to minus 10 meter. Now, what is the uncertainty in momentum of an electron? So, from Heisenberg's uncertainty principle, delta x, delta p is equal to h upon 2 pi. Therefore, delta p is equal to h upon 2 pi delta x. Substitute the value h 6.6 into 10 is to minus 34 upon 2 by 3.14 and delta x is given 10 is to minus 10. As we simplify, we get the answer 1.05 into 10 is to minus 24 kg meter per second. Okay. After that, the next question asked in 2018. If energy of the photon of 6,000 angstrom is 3.2 into 10 is to minus 19 joule, then the energy of photon with 4,000 angstrom wavelength will. Now we know that when the lambda 1 wavelength is given 6,000 angstrom, at that time the energy E1 is equal to 3.2 into 10 is to minus 19 joule. When the lambda 2 is equal to 4,000 angstrom, we have to find out the E2. Now the energy of photon, we know that E is equal to HF is equal to HC upon lambda. Now here the H is constant, C is also constant. Therefore, H is constant. So, from this equation, we can say that the energy is inversely proportional to the wavelength. E proportional to the 1 upon lambda. And due to that reason, now we take the ratio of E2 upon E1 is equal to lambda 1 upon lambda 2. E2 upon E1 is equal to lambda 1 upon lambda 2. Therefore, E2 is equal to E1 lambda 1 upon lambda 2. Now we substitute the value E1 3.2 10 is to minus 19 into lambda 1 is given 6000 angstrom divided by 4000 angstrom. Angstrom cancel, this 3 0 are cancel. 6 by 4. That means the 3 by 2. 1.5. Therefore, the answer is 4.8 into 10 is to minus 19 joule. That is the energy of photon having the wavelength is 4000 angstrom. Very numerical. If the energy of the photon of wavelength 6000 angstrom is 3.2 into 10 is to minus 19 joule, then the energy of the photon with 4000 angstrom will be. So we know that the energy of the photon is equal to Hn. Here the frequency is not given, the wavelength is given. Therefore, E is equal to hc upon lambda. Therefore, E proportional to 1 upon lambda. Right? So from this equation, E2 proportional to 1 upon lambda 2, E1 proportional to 1 upon lambda 1. Taking the ratio of E2 to E1, therefore E2 upon E1 is equal to lambda 1 upon lambda 2. Therefore, E2 is equal to E1 into lambda 1 upon lambda 2. Substitute the value, we obtain the answer is 4.8 into 10 is to minus 19 joule. Clear? Okay. Now the next numerical, that is the extra numerical. Okay, electrons should be accelerated by which voltage so that its deep Broglie wavelength becomes 0.4 angstrom. There is a same as the earlier. We get the equation of the electron accelerated by the V voltage. What is the deep Broglie wavelength? Here, deep Broglie wavelength is given. We have to find out the voltage. By this voltage, the electrons are accelerated. So we know that the deep Broglie wavelength of an electron lambda is equal to h upon under root of 2 EVM. Making the square, therefore we obtain lambda square is equal to h square upon 2 EVM. We require this voltage. Therefore, V is equal to h square upon 2 EM lambda square. 2 EM lambda square. Substitute the value as 6.6 10 is to minus 34 whole square divided by 2 charge of an electron 1.6 10 is to minus 19. Here M should be the mass. M should be the mass because the electron is given mass of an electron 9.1 10 is to minus 31 kg. And now lambda is given the 0.4 angstrom. Therefore 1 angstrom is equal to 10 is to minus 10 meter. Therefore 0.4 into 10 is to minus 10 meter whole square. So as we simplify, we get the answer is 940.5 volt or approximate 941 volt. So this electron must be accelerated by the 941 volt. So its wavelength becomes 0.4 angstrom. Again, the electron should be accelerated by which voltage so that its deep Broglie wavelength will becomes the 0.4 angstrom. For that purpose, here deep Broglie wavelength is given. We have to find out the voltage. Therefore, the equation of the de Broglie wavelength relate with the voltage. Therefore, lambda is equal to h upon under root of 2 EVM. Making the square both sides, lambda square is equal to h square upon 2 EVM. We require the voltage, take the voltage on left hand side. Therefore, V is equal to h square upon 2 EM upon lambda square. Now we substitute the value as 6.6 10 is to minus 34 whole square divided by 2 E charge of an electron 1.6 into 10 is to minus 19 M mass of an electron 9.1 into 10 is to minus 31 into lambda. Lambda is given the 0.4 angstrom, convert into meter, 0.4 into 10 is to minus 10 meter and whole square this. Therefore, 940.5 volt, it means the 941 volt is required to obtain the de Broglie wavelength of an electron is equal to 0.4 angstrom. Good morning, friends. Now, the next numerical, the extra numerical may be probability of to ask in exam. Up to this, these questions are not asked in any exam. So, work function of a metal is given 4.2 electron volt. It is irradiated with the photon of 6.2 electron volt energy, which is the ultraviolet light. Its stopping potential will be. Now here the one metal surface is given, having the work function is 4.2 electron volt. That means the phi 0 is equal to HF 0 is equal to 4.2 electron volt. Now UV light, ultraviolet light. In this light, the photon having the energy is 6.2 electron volt. Therefore, the energy of the photon incident is 6.2 electron volt. Now, what is the stopping potential of this metal? We have to find out the V0. Again, the work function of the metal is given the 4.2 electron volt. It is irradiated with photon of 6.2 electron volt of ultraviolet light. Now, its stopping potential is. Now we know that the maximum kinetic energy of emitted photoelectrons, half M square maximum is equal to EV0 is equal to HF minus HF0. From Einstein's photoelectric equation, M square maximum is equal to EV0 is equal to HF minus HF0. HF is the energy of incident photon. HF0 is the work function of the metal. Therefore, EV0 is equal to HF minus HF0. HF and HF0 are given 6.2 minus 4.2. That means the 2 electron volt. Thus, we obtain EV0 is equal to 2 electron volt. E cancel. Therefore, value of stopping potential is 2 volt. Again, from Einstein's photoelectric samikran, half M square maximum, Einstein's photoelectric equation, half M square maximum is equal to EV0 is equal to HF minus HF0. We are using this concept. EV0 is equal to HF minus HF0. HF is the energy of incident photon, that is given the 6.2 electron volt. HF0 is work function. Therefore, 6.2 minus 4.2, that is the 2. Therefore, we obtain EV0 is equal to 2 electron volt. E cancel, therefore V0 is equal to 2 volt. Therefore, the value of stopping potential is 2 volt. After that is the most important MCQ question. Ratio of d bernoulli wavelength of hydrogen kept at 27 degrees centigrade and helium is at 127 degrees centigrade. The mass of the hydrogen is given the 2 SI unit. 2 SI unit. Its temperature is 27 degrees centigrade. That means 27 plus 273. That means 300 Kelvin. Similarly, for helium, mass of the helium is 4 SI unit. Temperature of the helium is 127 degrees centigrade. That means the 127 plus 273, 400 Kelvin. Now in one MCQ question, we obtain the equation of d bernoulli wavelength helium with its absolute temperature. So this equation is lambda is equal to h upon under root of 3m/kT. 3m/kT. K is the Boltzmann constant here. Now for given hydrogen and helium, Boltzmann constant is constant, K constant, H constant. Therefore, lambda proportional to the 1 upon under root of m. Lambda proportional to the 1 upon under root of m. So using this equation, we can add lambda H for hydrogen to the lambda for helium is equal to under root of mHe into Th upon m for hydrogen and temperature for hydrogen. Therefore, we obtain mass of the helium 4, temperature of the helium 400 divided by mass of the hydrogen 2, temperature of the hydrogen is 300. Therefore, root 8 by 3. Root 8 by 3. So here we have to find out the ratio of d bernoulli wavelength of hydrogen at 20 degrees centigrade and helium at 120 degrees centigrade. Mass of the hydrogen given 2 SI and mass of the helium is given the 4 SI. And temperature we convert into the Kelvin. We know the equation of the d bernoulli wavelength elect with its Boltzmann constant and absolute temperature. Therefore, lambda is equal to h upon under root of 3m/kT. K is the Boltzmann constant. Here h 3k constant. Therefore, lambda proportional to the 1 upon under root of m into t. Therefore, we take the ratio of lambda of hydrogen to the lambda of helium is equal to under root of mass of the helium into temperature of helium divided by mass of the hydrogen into temperature of hydrogen. So as we substitute the value, we obtain the answer is root 8 by 3. Now next, a proton moves with a speed c by 10. It means the 10th part of velocity of light in vacuum. So it's d bernoulli wavelength v. So the speed of proton v is equal to c by 10. C is already we know that 3 into 10 is 8 upon 10. Therefore 3 into 10 is to 7 meter per second. That is the speed of a given proton. Now, we require the d bernoulli wavelength lambda is equal to h upon p is equal to h upon mp into p. mp, mass of proton, that is given 1.67 into 10 is to minus 27 kg. Substitute the value 6.6 into 10 is to minus 34 upon 1.67 into 10 is to minus 27 and speed is 3 into 10 is to 7 meter per second. It is simplified, so we obtain the answer is 1.321 into 10 is to minus 14 meter. Therefore, 1.321 into 10 is to minus 4 angstrom. Very simple numerical, but here the speed of the proton is given in terms of c by 10. Therefore, we obtain first the speed of proton v is equal to c by 10. Since the velocity of light in vacuum 3 into 10 is to 8 divided by 10, therefore 3 into 10 is to 7 meter per second. Now, the lambda is equal to h upon p. Here, mass of the proton and speed of the proton is given. Therefore, the momentum of proton is mass into velocity. Therefore, h upon mp into v. H is substituted the value we obtain. The wavelength proton is 1.321 into 10 is to minus 14 meter. But here, in answer, all the wavelengths are given in angstrom. Therefore, to convert this meter into angstrom, we have to divide it by 10 is to minus 10. Therefore, 1.321 into 10 is to minus 4 angstrom. Now, a bulb converts 5% energy applied to it into the light energy from 100-watt bulb. How many number of the photon of visible light will be emitted? Now, listen. The 5% energy of applied is converted into the light energy by the bulb of the 100-watt. Therefore, efficiency of the bulb N is equal to total energy supplied, that is the 100 watt into 5%. Therefore, 100 into 5 by 100, so that is the 5 joule. Now, in this energy, suppose the n photon are present, therefore E is equal to NHF. Here the frequency is not given, wavelength is given, therefore we convert into wavelength is c upon lambda. We require the number of photon emitted per unit time, therefore n is equal to E lambda upon hc. E already we obtained, that is the 5 joule. Lambda is given 5600 angstrom, therefore 5 or 6 into 10 is to minus 7. See, velocity of light vacuum upon, so here the Planck's constant 6.62 into 10 is to minus. Now listen, the photon emitted per second, n is equal to E lambda upon hc. E is 5 joule, lambda is 5600 angstrom. Convert into meter, therefore 5.6 into 10 is to minus 7 meter. Divided by Planck's constant 6.6, 10 is to minus 34. Velocity of light in vacuum 3 into 10 is to 8. Now, as we simplify, we get the answer is 1.41 into 10 is to 19 photon per second. Photon per second. Again, there is the most important numerical. Here, the electric bulb of the 100 watt, it convert the light energy, electrical energy into the light energy by 5%. That means the 5% energy is converted into the light. Therefore, the total energy E is equal to 100 watt bulb. Now, efficiency is equal to E into 5%. Therefore, 100 into 5%, therefore 5. Now, in this energy, suppose the n photon are present, so E is equal to NHF is equal to NHC upon lambda. We find out the n, therefore E lambda upon hc. That is the 1.41 into 10 is to 19 photons per second are emitted. Now, the similar example is given. Instead of the 3%, 5%, here 3% is given. And wavelength is given 6625 angstrom. Calculate yourself by using the same equation. N is equal to E lambda upon hc. You get the answer is 10 is to 19 photon per second.